All right, today we have 5.7 graphs of sine and cosine. Yesterday, or last class, we did 5.6, which we just graphed some of the trig, um, just some of the trig equations. So today we're doing just sine and just cosine, and then kind of transformations with them. The sub should have given you this classwork. Should look like this. If you don't have it, make sure you get it. Um, and this will go with this video. So what I want you to do first is take out graphing calculators and graph these four equations in y1 through y4. You can pause the video and then resume it when you're done. Okay, so I have these all typed in here. If I hit graph, just go to a standard window. Actually, you're going to bear with me. This does not look right only because I should be in radian mode, and this is definitely in degree mode. That's probably why it looks like that. All right, let's try and regraph it. So this one right here is just y equals sine x. You'll get pretty used to seeing that one. This one is 2 sine x. So you can kind of see what the 2 does to it. It's a vertical stretch by 2 if you think about what we did back in Unit 1. This one is a vertical translation up 1, right? Or just a translation up 1. And then that last one is like a horizontal shrink by 2. If you can see, it's kind of compressed horizontally. But in all of those equations, we've seen these before, right? A 2 on the outside, a vertical stretch by 2. A plus 1 means a vertical or translation up 1. A 2 on the inside is kind of like opposite the common law or whatever your common sense would tell you. It's actually a horizontal shrink by 1/2, right? Or by 2, that's fine, by a factor of 2. So with trig functions, they follow the same rules all the other functions we did back in Unit 1, where the numbers on the outside or inside are going to be changing what the shape of the graph looks like. So basically you have like a standard form, which is really these two. These first two right here that you see up top, they're the same ones except for they don't have any um, translations. So there's no H and K, so it didn't move left or right or up and down. But these are the two that you'll need to worry about because you'll deal with translations. Right? So if you think about what the A value does, that's pretty much dictating one of two things. Um, one, it's tells you if it's a vertical stretch or shrink, right? So we're going to say vertical stretch or shrink. And it's also, if you remember, if A is negative, it's going to be reflection over, right? And so the negative on the outside changes anything vertical, which is going to be all the y values that change. It's a reflection over the x-axis, right? I'll just put if negative. And that's kind of what the A value is responsible for. Now, it's also going to be something we call the amplitude, which we'll learn about as we go through the slides. But that's kind of what A is controlling. If it's vertically stretch or shrink, right, it's stretching if it's bigger than 1 or less than -1, and it's going to be vertically shrinking if it's something between 0 and 1, or -1 and 0. Um, the B value is kind of put in here, but again, it's kind of tied with the X. It's on the inside, so those are the ones, if you remember from Unit 1, those are horizontal stretches and shrinks, or compressions, if you want to think of it that way. And that's really all that you'd have to worry about. It could be, if it's negative, it would be a reflection over the y-axis. We don't really deal with them, but if you think of the A as a reflection over the x-axis, the B, if it's negative, is going to be a reflection over the y-axis. But again, these B's kind of go opposite common logic. It's, if it's bigger than 1, it's actually a shrink, and if it's something between 0 and 1, it's actually a stretch. B is going to be something else that we're going to call the frequency in a little bit. But just so you know, it's kind of compressing it horizontally or stretching it out horizontally. H would be a translation. If you remember, it's almost like vertex form. It is like vertex form. H is left and right. So it's a translation left and right, which we're just going to end up calling them phase shifts or phase displacements. It's just another word basically for a horizontal translation, which we use more in trig, especially with these sine and cosine graphs. So that's basically controlling left and right movement, and then the k is controlling up and down movement. We're just going to call those vertical shifts or vertical displacements. And that's kind of the verbiage we're going to use here. So it's a little bit different than just translation, but it's essentially they're doing the exact same thing. So, like I said, A in this formula is going to be something we're going to refer to as the amplitude, right? The absolute value of it is going to be the amplitude, which just means if it's negative, what is it doing? It's just going to reflect over the x-axis, right? But the actual value of A, the numerical value of A or the absolute value of A is going to be the amplitude. So, it's basically how high the graph gets or how, the average of how high it goes versus how low it goes, right? So if this goes up to 1 as a y value, it goes down to -1. So that's a distance of 2 units. You take the average to get 1 unit. But basically, if you drew a line in the middle, that's kind of how we can think about these. If you drew a line right through the middle of the graph, like that, it's the distance from the middle up or to the middle down. Notice how it's both 1 unit either way. So the amplitude is 1, which in the equation, it's 1 times sine x. So like the a value is 1, so you kind of see it both ways. So you can see it on the graph, right? This distance here is 1 unit, or this distance here is 1 unit. And in the equation, it's just a number in front of, it's the first number actually. This one's 2 sine x, so you can tell that the amplitude is definitely going to be 2. And again, if you had to draw what we call, it's called a wave axis when you draw it right in the middle. But basically this distance now is 2 units, right? It goes from 0 to 2. Or this distance from here to here is also 2 units. So you can see it in the equation, you can see it on the graph. This one right here, sine x plus 1, the amplitude is 1 because there's a 1 out in front. And it's just that the wave axis, the line you would draw right through the middle of it, I kind of misdrew that, but whatever, right? This distance would still be 1 unit, right? This distance from the middle up would still be 1 unit. So it's still an amplitude of 1, just this plus 1 means it's a vertical shift of up 1. All right, so that's it for amplitude. The other thing, which is the b value, so we've done the a value. The b value next is something called frequency, which is, essentially how like this would have a higher frequency because there's more curves. It's almost the same thing as wavelengths. Higher frequencies would just mean more. They're almost compressed horizontally, which they are. But you can also get it from the equation. So the frequency, the technical definition for you is going to be the number of complete curves you see in a 2 pi unit long interval, right? So we'll talk about that in a second. And then it also relates to period, which is the next slide. But for us in the equation, it's basically the number that's in front of x. So if you don't see anything, then it's 1. So in this case, it's sine of x, or the same thing as sine of 1x. So the frequency is 1. And all it means in terms of the graph is if you had a 2 pi unit long interval, so like from 0 to 2 pi, which is like 6.28, it just means the number of complete curves that you see within that space. So you can kind of see you only have one full curve, right? It goes up, it goes down, and it's right back to where it started, which is back here. So in a 2 pi unit long interval, there is only one full curve, right? Now this one is sine of 2x, so the frequency is 2. That's the b value frequency. And if you notice now, between 0 and 2 pi, you will see one full curve, two full curves. Frequency is 2. It matches the 2 in the equation. This one is sine of 0.5x, so the frequency is just 0.5. Amplitude on all these is 1, but the frequency here, again, if you have a 2 pi unit long interval from 0 to 6.28, that's 2 pi, you actually only see a half of a curve. The other half is over here. So that's kind of why the frequency is 0.5. So that's 2 out of the 3. We've done amplitude, we've done the frequency. We know that this is a phase shift or displacement. We know this is a vertical shift or displacement. But there's something else not in the equation that we want to know about trig graphs, especially sine and cosine, and that's the period. So the period is basically not in the equation, but you can get it by doing 2 pi divided by the frequency, which is b, right? And this is a very important part. It's basically the distance in between high points, or the distance in between low points, or the distance between x-intercepts as long as it's going in the same direction. So like this is going up here, so we don't actually want this x-intercept because it's going down, so we want the next time it's going up. But that distance, right, this distance here, or is the same thing as the distance between low points. It's the same thing as the distance between high points. Those are all essentially a period, right? So the technical definition, the length of the shortest interval on the x-axis before and after which the y values repeat. Basically just think of it as the distance between high points, low points, or sometimes it's really helpful to do x-intercepts because if it's an x-intercept, you can see the values here. And sometimes it might be hard to kind of figure out if it's 6 or if it's 6.28 if you're looking at high points. But if you're looking at, actual values on the x-axis, it could be easier to see. But here, the period, right, it's y equals sine x, so the period's not in the equation. You have to do 2 pi divided by b, which the b is 1. So the period here is 2 pi, right? So this distance from here to here is 6.28, it's 2 pi, right? This, again, the x-intercept may be better to use. From 0 to, okay, it's definitely a little bit bigger than 6. It's 6.28, it's going to be 2 pi. Sine of 2x, right, it's going to be 2 pi over b, which now the b is 2, so 2 pi over 2, right? The period is actually just going to be pi. So what you notice is with a higher frequency, the period is smaller, right? It's going to be 2 pi over 2. So this distance between those low points is 3.14. That's pi, right? Same thing from here to here. You can see it's definitely a little bit bigger than 3 because 3 is right there. So it's 3.14, right? Or high point, same thing, 3.14. Now this one right here is going to be 2 pi over b, which in this case is 0.5. So 2 pi divided by 0.5 is the same thing as 2 pi times 1/2, divided by 1/2, so 2 pi times 2, which is just going to be 4 pi. So what you notice is I can't really start here because I don't have 4 pi across, but if I look at, like right here, it's negative 6.28, which is negative 2 pi, right? That distance between here and then here, it's doing the exact same thing. It's kind of going down and intersecting, going down and intersecting. So all it means is this distance here is 4 pi, right? Notice how I can't use high points and low points because the graph doesn't have another high point. It doesn't have another low point, so you kind of have to use the x-intercepts there. But all it means is the period is 4 pi. The distance from here to here is 4 pi. So basically, if you're going to sketch these without using a graphing calculator, that's essentially what we want to get to. There's a couple rules that we want to know. And you probably want to do these in simple steps, but start with the parent function. If it's sine of x, start with that. If it's a cosine equation, start with a cosine equation. And then just work off of that, right? So the next 2 steps, or even tips, if you want to think of them that way, figure out the amplitude and figure out the period and then space them out the right way. I generally do amplitude first. So if the amplitude is 2, all of my high points go up to 2 and down to negative 2 instead of up to 1 and down to negative 1. If the amplitude is 1/2, they only go half as far. And then from there, you can figure out the period because you don't really need to use frequency directly on the graph. It just kind of works out. So figure out what the period is and then space out your high points that distance, or space out the low points that distance, or space out the x-intercepts as long as it's going in the same direction that distance. And then basically the tip 4 is almost a check. If you spaced it out correctly, the frequency should match, right? So if you looked at a 2 pi unit long interval, you should have that many curves. Whatever the frequency is, you should have that many curves. And it's not really a separate step. That's why I highlighted it in different color. It's almost like a check to make sure that you did step 3 correct. And we'll explain that as we go through an example. And then step 5 is last. You can just do your translations. You should do if you have reflections, do those first, and then do translations second for the last thing to do. But for a lot of your problems, you just have translations. Just move it up, down, left, and right after you've taken care of these steps. Let's take a look at this example. We have f of x is equal to 2 sine 3x plus 1. So the amplitude is 2, frequency is 3, and then we have a vertical displacement of up 1. So what we first want to do is start by graphing the parent function, which would just be y is equal to sine x. So first step, parent function y equals sine x, we'll graph that. So let's grab this. Okay, so if you think about sine of 0, if you want to draw a unit circle like we did for yesterday's lesson, that's fine. But basically sine of 0 radians is just a y-coordinate of 0. So we have 0, 0. Pi over 2, the y-coordinate there is 1. Keep working our way around. At pi, it's back down to 0. 3 pi over 2, the y-coordinate is negative 1. And at 2 pi, it's the same thing as it is at 0. So negative 2 pi would obviously be the same thing. Negative 3 pi over 2 would be the exact same thing as pi over 2, which is just 1. Negative pi is the same as pi. And negative pi over 2 is same thing as 3 pi over 2. So essentially, this is going to be our shape for the parent function. Okay, so next thing we want to do, again, is just do the amplitude. So we can see here the amplitude is 2. So I'm going to do the amplitude part with 2, which just means instead of a high spot of 1, it's just going to be dragged up here to a high spot of 2. Right? Same thing over here. Up here is just going to now be 2. It's basically just being vertically stretched by 2. But also down here, instead of going to a low point at negative 1, it's now going to be negative 2. And a low point here of negative 1 is now going to be negative 2. But all the zeros, when you multiply all those by 2, they stay the same thing, because 0 times anything is 0. So then we can basically just connect the dots here, and then we've taken care of the amplitude, right? So that right there is a graph of 2 sine x, right? That takes care of the amplitude. We have sine down. The next thing we want to do is space out so we can get the period, and this is by far the hardest part of the whole thing is just kind of this part. It's probably the most difficult one to remember. So I'm going to do this one in purple. But you can get the period from taking the frequency in the equation and saying, okay, well, the period is going to be 2 pi divided by the frequency, which is 3. Right? Now, 2 pi over 3 sounds like it could be difficult for spacing, but really, just think of pi as the same thing as 3.14. So it's like 3.14 over 3. They almost are essentially the same thing, so they pretty much cancel. So the spacing is going to be pretty much just 2, right? 2 pi over 3 is like 6.28 over 3. It's a little bit bigger than 2, but not that much. So on your spacing, what you want to do is look at the y-intercept, which is just 0, 0. And all a period means it's going to be the distance between high points and low points, but also x-intercepts where they're doing this, where they're going the same direction. So basically a little bit more than 2 later, since that's the period, the graph is going up right here, so a little bit more than 2 later, it's going to do the exact same thing. A little bit more than 2 later, it's going to do the exact same thing. So I'm doing like little tick marks to show myself that the graph should be going up in these points. So I don't want to connect from here to here because that's not doing the same thing. That would be going down and intersecting. I want to go all the way up to 2, all the way down to negative 2, and then go back up just like I was 2 units before. And we can even go a little bit further than -2. We can get some on the negative part too. But that's it, right? So essentially, the amplitude is 2. So you have to go up to 2, down to 2, and then hit that spot. And then up to 2, down to -2, hit the next spot. Up to 2, down to -2, hit the next spot. And you'll space it out pretty good. It's not going to be perfect, but it's going to be pretty darn close. And that's going to take care of the period for you. So that's what we're going to do next. And that is something that takes care of the period. So what you can see is basically the distance between high points is pretty much 2. The distance between low points, it's 2 pi over 3 exactly, but you can see it's spaced out. It's not perfect. This maybe looks like a little bit bigger, but it's not. It doesn't really look too bad, and that's fine. And then basically, again, step 4 was just a check, right? The frequency is the number of full curves that you see in a 6.28 or 2 pi unit long interval. So if I look from 0 to 2 pi, I should see 3 full curves. Now I didn't really extend it all the way, but I certainly could. But what you kind of see here is, all right, so I got boom, 1 full curve, and then boom, 2 full curves. And if I did extend it, I probably should have, but I would have another 3rd full curve. If you want, I could look between 3 pi over 2 and -pi over 2, since that's a 2 pi unit long interval, and say, okay, 1 full curve, 2 full curves, and then 3 full curves, right? Which makes sense because your frequency is 3. So you're not doing anything in this step, you're just checking to make sure that you did the period right, and that's what the frequency does, because they're related. If you did the frequency right, you did the period right, and vice versa. Now the last thing we have is transformations, which this one's just going to be +1, so it's just up 1. So what I'm going to do, I'll do this in red, and that will take care of the final thing. So basically all of these high points, I'm just going to move them all up 1. All of my low points I'm going to move up 1. I can move all of my x-intercepts up 1 just to kind of get a good baseline of where I want to do this. But you probably only need the high points and low points, and really just connect them at that point and you'd be okay. And that is it. You don't have to fill up the whole graph paper, although you certainly could. But that would be your final graph. So I mean, it's good if you have colored pencils for a day like this, just because you're going to be graphing a lot of things on top of each other, so it helps to see it. But that's it. 2 sine 3x plus 1. So this is the second example. I would encourage you to pause the video, maybe just try it on your own. But if you want to see one more, that's fine. You can certainly just follow along. But it's going to pretty much do the same thing. And you might be surprised with how well you can do on your own. But it's your call. But here we have cosine of, or negative cosine 2, and then x minus pi over 2. So notice how the frequency goes on the outside of the parentheses. That's normal. Your calculator will automatically create a parentheses, so if you would just need to create another set of parentheses if you were going to graph it on your calculator, but that's okay. So what we're going to do first is the parent function. I'll do that in red. So the parent function is just cosine of x. So cosine of x, we're going to look at cosine of 0, which is the x coordinate 0, so the x coordinate's 1. At pi over 2, the x coordinate is 0. At pi, the x coordinate is actually -1. At 3 pi over 2, it's back to 0. At 2 pi, it's the same thing as where it started. So you can kind of just go in this shape all the way through. All right, so that's cosine of x. Next, we're going to do the amplitude, which if you look at the amplitude, it's actually 1. The negative doesn't mean amplitude's negative. It just means that you're just looking at the actual number out here. So it's 1, so we're actually done with the amplitude. We don't have to do anything there. The period is what's next, which again is the hardest part. So the period here is not in the equation, but it's always 2 pi over the frequency, which the frequency is 2. So it's 2 pi over 2, which is just equal to pi, which just means that the spacing should be a little bit bigger than 3 units apart, because 3.14, I can't really tell that difference. A little bit bigger than 3 is fine. So again, you look at what you're doing on the y-intercept. That's always going to be your compass for where to do the period from. So I have a high point at the y-intercept. With sine, I had going up and crossing the x-axis. But with cosine, I have a high point. So all I need to do is going to say, all right, since the period is 3, or a little bit bigger than 3 at pi units later, I will have another high point. Another pi units later, which is 2 pi, I am going to have another high point, which I already had one there. Negative pi, same spacing, negative 2 pi, another high point. And that's it. So that's going to be kind of all the high points in between. So all you need to do, since the amplitude is 1, just kind of stay at 1, go down, and then back up, and hit that high point. And then down, and back up, and hit that high point. And what you notice is halfway in between the high points would be a low point. So you can fill those in first, but you don't have to. As long as you kind of space it out evenly, you should be okay. Okay, so that right there is a graph of cosine of 2x. I took care of the frequency, I already had the cosine, and I took care of the amplitude since it was just 1. But again, what you notice and what is that the spacing here, from here to here, should be a little bit bigger than 3, right? Right here, we got 1, 2, a little bit bigger than 3. Same thing from here to here. High point, right? 1, well, we had from 0 to pi, that's easy to see. But you can check it out in different spots. Right here in x-intercept, it's going up. We got 1, 2, 3, boom, another x-intercept that's going up. So that takes care of the period for us. The frequency, again, is just a check. If I look at a unit that, or a 2 pi unit long interval, so like from 0 to 2 pi, I should see that number of full curves, which is the frequency, which again, the frequency is 2. So now I should see 2 full curves within this 6.28 unit long interval. So I have 1 full curve, boom, 2 full curves. Again, that will always work out if you do the period correctly. And then the last thing is transformations. So I have 2 of them. I have a reflection over the x-axis, and I have a phase shift of pi over 2 units to the right. So you do reflections first. So what that negative is going to do is take all of my high points, this in purple, and now make them low points. So this high point is now actually going to become a low point. This high point is actually now going to become a low point. Right? This high point is now a low point. This high point is now a low point. All the low points, since it's reflecting over the x-axis, they're actually going to become high points. Almost is going to look like a DNA strand in a way. And, that's all I'm going to do. You can go all the way across, but you don't need to. And that takes care of the negative sign. And then finally, I'm going to shift everything to the right pi over 2 units. So I'm working off the purple one, and then I'm going to shift it pi over 2 units to the right. So I'm actually right back there. This one, another purple one, I'm at pi, so pi over 2 to the right is going to be 3 pi over 2. I can take this one, again, pi over 2 units to the right. So it's like 1.57, but it's already clearly marked here. You get negative pi over 2, that's pi over 2. And what you notice is, and then all the high points, I can do the same thing. So pi over 2 units to the right, pi over 2 units to the right. What you notice is actually I end up being right on top of the green one that I already drew, which is just more coincidence than anything else, but the reflection tagged with the phase shift actually just recreated the same green one that I had. So instead of redrawing it, just kind of realized the green one is actually the final. Well, I'll redraw it anyways. And that's actually the final graph right there in black. And that takes care of the transformations. So what you guys can do now is basically you've seen two examples. Go ahead and start the homework. You can't really ask me questions because I'm not there, but definitely check the key. But I would encourage you to rewatch the video if you're stuck, especially with the period. Know to start with the y-intercept, but you should be okay from there. Thanks.